Alright, so we're continuing on from the last video. So I was left with something that looked a little like this. So what we've got here is something quite different to actually what I expected. I kind of made up this example. So I'm going to have an answer that's going to be e to the at hyperbolic sine of bt, and I'm going to have an answer that's e to the at hyperbolic cosine of bt. And the reason why I say that is because of this minus sign here. If this was a plus, there would be no hyperbolics. It would just be the normal trigonometric functions. But because there are hyperbolics, there are minus signs in between these two terms, there is a hyperbolic factor. And this is given from the table of Laplace transforms. You can find this on Google Images. So what do I do here? So to find out if you want to take the Laplace transform of e to the at cosine hyperbolic of bt, that's going to give you, reading this off of a table, s minus a over s minus a squared minus b squared. And the Laplace transform of e to the at hyperbolic sine of bt is equal to, I have to look, sorry man, forgive me. That's just going to be b over s minus a squared minus b squared. Alright, so now that we've figured that out, why is that important? So now I can look at this and pretty much figure out what I have to make this work. So, I'm sorry about the shadow here, I'll fix that right now. So, I'm going to deal with the easiest part first. I was about to do the hardest part, but I'll do the easiest part. So, let's do this minus 21 over 28 first. So minus 21 over 28, and that's multiplied by the inverse Laplace transform. And what I'm going to do here is I'm going to multiply top and bottom by the square root of this. So this is going to be square root of 93, because square root of 93 is irrational. And the square root of 196 I know now is 14. And that's all over s plus 11 over 14 squared minus 93 over 196. And then I have to multiply the bottom by square root of 93 over 14. So, what happens here? Well, this is now just going to be equal to negative 21 over 28 multiplied by the reciprocal. So that's going to be 14 over the square root of 93. And then 14 and 28 are going to cancel. This is divided by 14 is going to be left with 1. Divided by 14 is going to be left with 2. So this is going to be equal to now negative 21 over 2 root 93. Now any good mathematician would, multiply top and bottom by the square root of 93, because you can't have square roots in the denominator. It's just, not nice look. I'm an engineer, so I can do what I want, so haha. Oh wow, I can't believe what I've become. And now this is I have an answer for this right now. This is going to be e to the minus 11 over 14t hyperbolic sine of bt, and b is the square root of 93 over 14. T. I almost forgot the T. Alright, that's an answer right here. But now I have to do the hard part real quick. So let's do it right now. So 1/7 the inverse Laplace transform of S. Now I have to get S minus A. So plus 11 over 14 minus 11 over 14 all over S plus 11 over 14 squared minus 93 over 196. Alright, and now that's going to be equal to 1/7, the inverse Laplace transform. Now I can split the fraction, and that's going to be s plus 11 over 14 over s plus 11 over 14. You know what I'm about to do, but and then that's minus 11 over 14, but I'm about to multiply top and bottom by square root of 93 over 14. These guys are going to cancel, and that's multiplied by the inverse Laplace transform of, you guessed it, square root of 93 over 14 all over s plus 11 over 14 squared minus 93 over 196. Oh my gosh, this is just annoying at this point. Now you can see why the video had to have two parts. So this, by the way, this 1/7 is distributed to both terms. So now I have an answer right here. This is 1/7 e to the minus 11 over 14t hyperbolic cosine, my only hyperbolic cosine term, of square root of 93 over 14t, and then that's minus 11 over 7 root 93 hyperbolic sine, e to the minus 11 over 14t hyperbolic sine of the square root of 93 over 14t. So let's write out our final answer, and that's equal to, so this is probably like one of the hardest ridiculous questions I've had. So the final answer, I haven't simplified this answer, but this is the final answer non-simplified. So that's 1 over 7. Okay, let's write it. E to the minus 11 over 14t hyperbolic cosine of square root of 93 over 14t minus 11 over 7 root 93 e to the minus 11 over 14t hyperbolic sine of square root of 93 over 14t, and then minus 21 over 8 root 93, okay? That seems, oh, that's 2. Yeah, that was a 2 because the 14 and the 28 cancelled. That's right. So minus 21 over 2 times root 93 e to the minus 11 over 14t hyperbolic sine of the square root of 93 over 14t. So remember in my, one of my examples, this is the final answer, by the way. Remember how I said that if you had like an inverse Laplace, your cosines and sines are generally going to have the same value here inside the function. So that was held true for even this example. Anyway, that's the answer. And from now on, I'm probably going to make this look nicer. I'm sorry about that. I'm sort of writing on an angle, so it's sort of hard for me. But yeah, that's the answer. So just one more time, 1/7 e to the minus 11 over 14t hyperbolic cosine of square root of 93 over 14t minus 11 over 7 root 93 e to the minus 11 over 14t hyperbolic sine of the square root of 93 over 14t minus 21 over 2 root 93 e to the minus 11 over 14t hyperbolic sine of the square root of 93 over 14t. That was a mouthful. Alright, see you later.